For example 1, I'd like to solve the linear inequality 2x minus 5 is less than negative 1/2 x plus 5. If you notice, this is almost the same example that was in the previous lesson. I just replaced the equal sign with a less than symbol. From the previous lesson, we know that where they're equal is where they intersect, and we figured out that our answer was 4. To answer an inequality, if you have all of this information, it becomes very, very quick to get your answer once you understand how the graph works. So what I'm going to do is just label a few things just as we did last time. The red graph I'm going to call f of x, and the blue graph I'm going to call g of x. And we saw last time that, oh, well, this side was f, the other side was g, but this is going to be different. What we're solving for in this case is, where is f of x less than g of x? So instead of equals, where is it less than? So what this statement is saying is, where are the y values of f less than the y values of g? And then all you have to give for your answer are the x values where this happens. So I'll tell you ahead of time that the answer can't be 4. That's where they're equal. But there's only going to be 2 possibilities. The answer is going to be either stuff that's less than 4 or stuff that's greater than 4. All right, going back to the idea here, we're comparing y values. Again, where's the y value of f lower than the y value of g? I can read this completely off of the graph as follows. So here's f of x. If I check out the values starting here and moving in this direction, the y values of f of x are less than the corresponding y values of g of x. The reason for this is because you have to go up from f of x to g of x. These are above these. That means f of x is lower than g of x, or f of x is less than g of x. That happens for all of these values. That means the corresponding x values are from 4 down to minus infinity. And that's the answer to the question. You could say the answer is x is less than 4, or if you wanted to use an interval, you could say that's everything from negative infinity up to, but not including 4. And this would be the answer to the problem. Both of those would be acceptable. But that's what I mean about it being nice using a graph. If you know where they're equal, and you have that number, but then you want to figure out an inequality, there are only 2 possibilities, less than or greater than. And it was on this side where f of x was lower than g of x. Now, it might be worth checking out what happened on the other side, like what happened if x was bigger than 4. So here's f of x, and here is g of x. Notice that all the values of f of x are above the corresponding values for g of x. This means that f of x is above or greater than g of x. That is not what this inequality is asking for. It's asking for the opposite. So if you look here and say f is bigger than g, I know that I do not want to use any of these x values. And it turned out that it was the ones on the left side of 4 that did in fact work. In example 2, we're going to do a similar thing where I want to solve this inequality, but I'd like to use this graph to figure it out. Where is negative 2x plus 8 greater than, or in this case, equal to negative 4? And I give you that they intersect at 6, negative 4. So I'm going to label that point here. And that is that x is equal to 6. The answer to this question is either x is greater than 6 or x is less than 6. We have to decide which of those 2 possibilities makes this true. All right, let me start labeling some things on the graph. If I call f of x the red graph, that clearly has to be negative 2x plus 8. And I'll call the blue graph g of x, and that is definitely negative 4. It's just a horizontal line. And I know where the 2 are equal. What we are looking for here is, where is f of x greater than or equal to g of x? Where are the y values of this greater than or equal to the y values of this? Here's where they're equal. So in this case, I do want to include 6 as my answer, but I'm left deciding, am I going in this direction or am I going in this direction? All right, if the answer were, let's say, moving in this direction, I could travel along the graph and say, okay, over here, is f of x greater than or equal to g of x? No. Notice that the g values are above the f values. So that means g of x is actually greater than f of x. So I don't want any of this stuff. So let's check out the other side just to make sure that it's true. If I move in this direction, here are the g values, here are the f values. Is it the case that f of x is greater than or equal to g of x? So here's f of x, here's g of x. Yeah, all of the f values are above the g values. So this means that the answer to this problem is everything including 6, but going in this direction. So that is x is less than or equal to 6 would be my answer. You could also use an interval notation and say everything from negative infinity to 6. Both of these are completely acceptable, but that is the answer to this example. It's worth asking if you even need a graph to solve an inequality. So this is the one from our previous example, negative 2x plus 8 is greater than or equal to negative 4. And it turns out that no, you don't need to use a graph if you don't want to. This one's easy enough just to solve by hand. The way it works is you can essentially treat this inequality as it were an equal sign and try to isolate x. But there's this one weird thing that you have to look out for, which I put as a fact. Anytime that you multiply or divide both sides of an inequality by a negative number, it'll change the direction of the inequality. So if that were to happen here, this greater than would flip to a less than. So it's worth pointing out that in the last example, the answer was x is less than or equal to 6. Like we figured that out from the graph. So let's work through this example without using the graph to see if we get the same answer. If I want to solve this for x, I'm going to subtract 8 from both sides. So that's my first step. Take away 8. This should have no effect on an inequality. If the left side is greater than or equal to the right side, and you decrease them both by the same amount, you should still have greater than. There should be no issues here. Negative 2x should still be greater than or equal to, in this case, negative 12. There's really only one step left to do, and that is to get x by itself. And to do so, you could divide both sides by negative 2. So I'm going to do that. I'm going to say I'll put a negative 2 here and a negative 2 here. On the left, it would just give you x. On the right, it's going to be a positive 6. If you were to just copy down greater than and put x is greater than or equal to 6 here, we would not get the same answer that we have in the previous example. It's for this reason that we're going to apply this rule. I just divided both sides of an inequality by a negative number. Anytime you do that, it'll change the direction of the inequality. And this is to ensure that our answers do in fact match up. So you could take this approach if you wanted to, just be careful to use this fact. Throughout the rest of the semester, we're really going to focus on a graphical approach just because it'll save us a lot of time. But if the example was easy enough, there would be nothing wrong with this process either.